So what are electron regions? That kept coming up over and over, and you kept seeing these pictures that kind of looked like that, kind of like these funny little shapes, and it kept saying electron regions. Well, the electron regions are only for looking at the central atom. That's the one in the middle. We ignore like all of this on the outside here, all those, you ignore those. For the shape of the molecule, it always comes from that central atom and how that central atom and the bonding electrons coming off of it, or the non-bonding, whatever they are, those are what give the shape of the molecule, not the external atoms electrons out there. Those are just hanging out, doing their own thing, doing some chemistry. So when we're doing these and we're counting regions, we're only looking at the central atom, and we're just looking for about where the electrons are. So there's a few tiny details about this to be clear. And this one is really straightforward, that, that phosphorus has got, 4 bonds. You know that there's 2 electrons in each bond, but you also know now that they all just move around like they're in some kind of craziness. And that's how you end up with kind of this shape. Although there's a little more to it that you're going to learn about coming up soon. But these are all moving around. They don't have a perfect linear shape. They kind of have a region they hang out in. And the region is shared between the phosphorus and the oxygen in this case. And you also will be finding out about how that sharing is. Sometimes that sharing is a little stronger on one element than on the other. So this would be 4 regions, and because it's 4 regions, and again, we are looking at the electrons, and this is electron geometry. Spoiler alert, there's another one that's coming along that has a few more names to it, and it includes some of the same names as electron geometry. All right, so there's another naming. This is not the only naming. This is the simple naming. On this one, you look at the regions around, you say there's 4, and so that's tetrahedral. Let's go over to here. Now, these regions may be less clear to you. First of all, you do know that already we'd looked at those single bonds. So these are regions. So right now, I'm done 4 regions. But there's still electrons there. There's a lone pair. Now, those electrons in the lone pair, they aren't going like all around the molecule. They are still being held between the xenon and the oxygen. They just are, there's just more electrons in that space. So maybe it could be a little wider, but this is still just considered one region. And then these lone pairs, they're causing all kinds of a mess because they are moving a lot about, and they're kind of hanging together, and they're kind of pushing everyone around. You'll find out more about that soon, but they are considered together to be one region. So it's kind of like, as you're looking through this, a region has at least 2 electrons in it, but if there's like a double bond, it can have like 4, it can have 8. So the regions are just like where we find the electrons. So this molecule has 5 regions, and again, the electron geometry, which is not the same as the molecular geometry, the electron geometry says that this one's shape is trigonal planar. And then we're going to look over here at this molecule. So we've got a single bond, and then again, that double bond just counts as a region. So this has 3, so this is trigonal planar. So trigonal planar. Now we're going to scroll on and look for just a minute on how we write things 3-dimensionally. So right here, this is actually a screenshot from the video. This, you can't see the second electron, but if you remember from the video at all, it did have, like it was like rolling this around through space. So imagine that it has that second electron in there. And you could see how it's 3-dimensional in the video. So what we do is we kind of have to pick how we're going to draw this. We usually pick something to just be on the paper because that makes it easier. So this part I'm going to pick to be on the paper. So we just keep it as a normal old line if it's on the paper. If it's like, see how this is behind, like it's hidden behind, it's almost like it's behind your screen because it's going back. We use a little dotted line, and there's a few different techniques. Some people use dashes, but a lot of people like to use like these little wedgie looking shapes, but they'll dot them. Some people will just dot it. But the idea is look for these dots, and that tells you that this one is going back. So if you see this online, and you probably will, like if you're looking for some more help online and you see dots and you're getting confused, that's what it means. It just means they're trying to give you a better visual of how it looks three-dimensionally. There's going to be a video coming up too where we actually move models around, so that should help too. And then this one, probably to you looks like it's in the board, but I don't know if you can tell that this part's kind of in front. So this one is actually coming out, like it's coming towards you. Like if you're looking at the screen, this one's going away from you. This one's coming out of the board towards you, about to hit your nose. So that one we do with a bright, strong wedge. So that's how we make this picture look like that one. I'm going to do another one. So in this one, the line's already drawn of the two that we're going to count as being like on the screen. And then also this one is all on the screen. The two that aren't, this is the back one, so that's the dotted, and then this is the front one. So we would just dot this one. And this front one will draw a wedge like that. And then on this one, it has a vertical line. So again, these vertical ones, we're going to draw like that. And you may not be able to see this as well, but both of these are coming towards you. It's like they're going to get to both of your ears. So the front two have got these wedgy shapes. Wedgy shapes, that's funny. They have these wedge shapes. And then these back two, they're going back, and so you'll see them with dotted lines. And I mentioned this because this shows up in charts. You'll see this in some of the charts that are coming up. And it's not like we're going to be really picky about asking you this. This is also leading into some organic chemistry. But it is important to be able to read a chart or just to see dots and wedges and not worry about them, to kind of understand what they mean.